Hi friends, so here in this video we are gonna learn a new concept called as functional dependence. Now let's say u is function of x and y and v is also function of x and y, and if we want to understand the relationship between u and v, that is whether u and v are dependent on each other or they are independent, then such scenario is called as functional dependency. And to find out the functional dependence, we use one condition. That condition is dou of uv by dou of xy, that is Jacobian of uv with respect to xy. Now if this condition is equal to 0, or if this Jacobian is equal to 0, then we say yes, u and v are functionally dependent on each other. But if we are not getting 0, then we say no, they are not functionally dependent. And if they are functionally dependent, then we can definitely find out the relationship between u and v. So let's understand this by using one example. So similarly, we can see the functional dependency between more variables also. Now let's say there is u, v and w, where u is function of x, y, z, v is also function of x, y, z, and w is also function of x, y, z. Now if I want to understand the functional dependence between u, v and w, then I can use the condition as Jacobian of u, v, w with respect to x, y and z. And if this condition is equal to 0, then I'll say yes, there is functional dependency between u, v and w. That is, we can find out that one variable is a function of other variable. So here we can find out that u is function of v or v is function of u. So let's understand this concept by using one example. So the example is, if u is equal to x upon y and v is equal to y upon x, then verify whether u, v are functionally dependent. So to check whether they are functionally dependent or not, we have to find out the Jacobian of u, v with respect to x, y, and it is given by the formula dou u by dou x, dou u by dou y, dou v by dou x, and dou v by dou y. So here we'll get dou u by dou x as 1 upon y, dou u by dou y as minus x upon y square, dou v by dou x as minus y upon x square, and dou v by dou y as 1 upon x. Now if we'll multiply the terms, then we'll get 1 upon yx minus x upon y square into y upon x square. So here if we'll cancel the terms x and y, then again we'll get 1 upon yx minus 1 upon yx, which is equal to 0. So as I explained you that if we are getting the Jacobian equal to 0, then we say yes, there is a dependency between the two functions u and v. So yes, here the dependency exists, and let's find the dependency between u and v. Now there is no fixed method to find out the dependency between u and v, but by using the values of u and v, but by making use of the algebra and some mathematical simplification, we can definitely find out the relationship between u and v. So here if you'll observe, then v is given as y by x. Now if I'll write this as 1 upon x by y, then you can say that x by y is nothing but u. So it clearly indicates that v is equal to 1 by u, or I'll say uv is equal to 1. and this is nothing but a functional dependence between u and v. Thank you.